Question 38 says, which of the following expressions, when evaluated, equals an irrational number? And as answer choices, we have a bunch of numbers with either radical 2 or radical 8 in them, as well as all these answers have different operations on those numbers. So some of them have division, some of them have multiplication or addition, etc. The only real pattern I'm noticing among the answers is that f and g seem to be reciprocals of each other, but that's like the main thing here. As far as the ACT math concepts in the prompt, the main thing is just this idea of an irrational number. And it's not uncommon on questions like these for students to see a word like irrational, which they may not know 100% the formal definition of, and sort of assume that they can't get it right from that point. So what I want to do on this question is I'm actually not going to define that term until the very end, until after we've tried to solve it. And I'm going to model how we might still think through this question or a question similar to this, even with an incomplete definition of what a word means. And this kind of problem-solving process where we're just going to take things one step at a time based on what we do know is a very helpful way of thinking in general on the ACT math, so we can generalize this to other questions as well. To start things off, let's just reread the question. So it was asking which of these expressions is going to be equal to an irrational number. So one other way of thinking about this is that if we don't know what an irrational number is, we can still keep in mind that apparently one of these answers is going to be somehow different or unique from the rest. So we could begin to approach this by trying to figure out what these answers actually represent as far as numbers go, and seeing if we can identify similarities or differences among them and try to find a unique one. In terms of how the answers are currently presented, it might not seem like there's any particularly big distinction among them. One thing we can try to do at this point is re-express the answers somehow, and there are a couple of different ways we could do that. One is kind of using more formal math knowledge. So for example, radical 2 over radical 8. One way we could begin to re-express that is the radical 2 can't be simplified, but the radical 8, we could actually split that up into radical 4 times 2. And then we can further simplify that because we can take the square root of 4, so we can pull out a 2 there, and that becomes 2 radical 2. And then from here, we have radical 2 on the top and bottom. We can cross both of these out, and we're left with 1 over 2. Another way of seeing this, if you're not as familiar with simplifying radicals, is we could also just plug this expression into our calculator and see what comes out. So we have radical 2 divided by radical 8, and that gives us 0.5, which is the same thing as 1 over 2. So we see that either way, we don't even need to know this process of simplifying radicals to kind of translate this into something a little bit easier possibly to interpret. Let's do the same thing for answer choice G. That's radical 8 divided by radical 2. Radical 8 divided by radical 2. That equals 2. And then for H, radical 8 squared. Again, if you know how these radicals work, anytime you multiply a radical by itself, since radical 8 squared is radical 8 times radical 8, what you're left with is just the number underneath the radical, and you could always confirm that just like we did over here on your calculator. And then for J, radical 2 times radical 8, this is going to be equal to radical 16, which is equal to 4. Again, that's using knowledge of radicals, but as before, we could just also do that on our calculator if we weren't familiar with that. So radical 8, we see it's 4. And then for radical 2 plus radical 8, let's try to do that on the calculator. Radical 2 plus radical 8. We get this number 4.242640687. So there doesn't really seem to be any pattern here in this number. I'm just gonna write the first 3 digits, 4.242, and kind of put ... to indicate that it keeps going. All right, so at this point, what we've done is we've basically re-expressed all of the answer choices in a way that might be a little bit easier to see what's actually going on. And our initial goal in doing this was to see if one of these numbers was unique in some way from the rest. And one thing we might notice here is that answers G, H, and J all seem to be of the same kind of number. Specifically, they're all integers, unlike these other two numbers that we have. So it seems safe to eliminate these, since if one of them were to be irrational, then these others would also seem to be irrational as well. At this point, we have it between F and K, and what we can do now is just go back and think about what this word irrational might mean in a general context. So if you say that somebody's acting irrationally or that somebody is irrational, it tends to mean that they're not really acting in a predictable, normal way, or there's not really order to their actions. And so going back to these answers that we have left, we have 0.5, which that seems pretty normal and ordered in that sort of sense. But then this other number, I'll pull it up again on the calculator, we had this long decimal, and there wasn't really any rhyme or reason to the numbers in that decimal. So if we had to make an educated assumption about which of these was irrational, it would obviously be K, and that does turn out to be the correct answer here. All right, now that we have solved it without really this definition of irrational, I'll go ahead and explain what that is. Actually, I'm going to start out with the definition of a rational number first. A rational number is any number that can be expressed as the ratio of two integers. On the other hand, an irrational number is any number that cannot be expressed as the ratio of two integers. I'm just going to put a space right here, and let's look at a few examples of each of these. And when we talk about an integer, just numbers like -2, -1, 0, 1, 2, 3, numbers like that. So for example, for a rational number, if we talk about the ratio of two integers, if we have 1/2, that is a ratio of two different integers. And as we saw, answer choice F is actually an example of that because it's 0.5. And so we can express that as, 1/2 over here. And then a number like 2, well, is there a way to express that as the ratio of two integers? Yeah, there's a lot of different ways, actually infinitely many. We could write 2/1, we could write 4/2. There's a lot of different integers like that. Same thing with 8. We could write that as 8/1. And then with J, we could write that as 4/1. On the other hand, there are no two integers that we could divide by one another that would give this repeating, or actually it's not repeating, this decimal number right here. And so this falls into this category of irrational numbers. A couple other examples of irrational numbers would be things like pi, and we can see that on the calculator as well. There's no two integers you can divide to get that number right there, which it's implied actually to keep going. Another example of an irrational would be something like the square root of 2. Again, there's not really any rhyme or reason to those numbers. And I'm just going to give a couple more examples of rationals, because the ones we saw here, they all are sort of similar in the sense that they're finite. But you could also have a number like 1/3, which also goes on forever. And that's technically a rational number, though, because even though it goes on forever, we have one integer divided by another integer. So technically, that satisfies that rational number definition. All right, now let's think about what we ultimately needed to know for this question to get it right. I'll type it out right here. Ultimately needed to know. So as we saw, even without the definition formally of irrational, if we recognize that G through J were all similar types of numbers, we were able to eliminate those. So G through J are all similar types of numbers. And in addition to that, we just needed sort of an informal understanding of the word irrational in everyday usage. And that allowed us to see that K would be an irrational, whereas F would not be. And finally, let's talk about the ultimate takeaways from this question that we're going to see apply to other ACT math questions. And the first of those is just the spirit that we took when tackling this question. So even though we didn't really know what irrational necessarily was in the beginning, we saw that we were still able to reason our way through the question with pretty much certainty about what correct answer we had. And we got there just by taking things one step at a time. We re-expressed what was given, and we began to see that there were sort of relationships among the answers that we hadn't seen before. And then we just thought about the meaning of the word, irrational, in a general context, and we got through the question. That is going to be the kind of problem-solving spirit that's very helpful on a lot of ACT math questions, because as we know, one of the main things the ACT likes to do is present questions in kind of unfamiliar, unusual ways. So inevitably, we're going to have to navigate through stuff that looks unfamiliar at first. And that leads to my final point about this question, which is that it's also very interesting how it was designed from the test maker's standpoint. If they wanted to actually see if we knew what an irrational number was in a very technical sense, they could have made these answer choices much more difficult. For example, we can imagine that maybe one of the answers could have been this other example of a rational number, like 1/3, where it is actually repeating, and that might have given people a little bit more trouble in terms of figuring out what is actually irrational. Another type of answer that they could have included that would have made this process we took much more difficult would be to include a rational number like 0.4, and this is just a random one, but 0.4173, for instance, which doesn't really seem to have any rhyme or reason in terms of like the numbers here, but that technically is a rational number because we could express this as 4173 divided by 10,000, but it would have been harder to eliminate that compared to like 0.5 or some of these other answers. And given what we know about the ACT in terms of how deliberate they are in writing their answer choices, it's illuminating to see how they've done it here, because it suggests that they were actually designing the answers to allow us to navigate through them with a possibly incomplete understanding of irrational. And that reflects sort of what we know about a lot of these questions, which is that the ACT rewards persistence and problem solving just as much, if not more, than memorization of formulas and other more advanced definitions of words. With all that said, let's go on to question number 39.